Flashing little B 20 amp ESCs with BlHeli using an Arduino Pro Mini today in Mikey's lab. Hey, and welcome back to the lab. Today we are looking at an interesting process. There's a lot of documentation on how to do this with a different style of Arduino. I don't have one of those particular types of Arduino, so I had to figure out how to do it with a Pro Mini. I figured that would be useful for you guys too. So lab code up. We're going to learn something today. For those astute and returning viewers of the channel, you may have noticed that there is now a combat robot playlist on our channel. That is obviously a project that's coming up, hopefully a beetle-weight combat robot. I've decided that for the drivetrain, I want to use brushless motors. Now, for those of you who don't know the difference between brushed and a brushless motor, I'm not going to dive too deep into it, but a brushed motor, basically you apply voltage one way and the motor spins one way, you apply voltage the other way and the motor spins the other way. They're generally very cheap and very easy to use, but I've chosen to use brushless, which you'll notice if you look at this one, has 3 wires coming out of it, and they require an ESC because they use phasing of the coils in order to spin properly. These tend to last longer than brushed motors, and you can get higher RPM out of them, which means we're going to have to gear them down, but that'll be another video. So I have a bunch of these ESCs, which when they came out of the package look like this. Right? Now these 4 here were actually off of one of my quadcopters. I'm trying to reuse as many parts as I can. So these are old ESCs that I believe have SimonK written to them originally. I know they're BlHeli compatible, so we're going to go ahead and write BlHeli to them. And we're going to take a look at configuring the ESC values in such a way that makes sense for use in combat robots. One of them obviously will remain very similar with only one direction rotation, but the others will need to be able to reverse in order to be able to drive a vehicle. The other one we're going to have to look at is regenerative braking. I don't know if the version of BlHeli that's compatible with this will be able to do that, but we'll take a look at the interface. We'll go through everything that's available, and we'll get these set up as much as we can today. So right off the bat, the first thing I want to do, we're going to take a look at the computer screen. You see that I'm running an old version of the BlHeli suite. This is important because these are not BlHeli S, so they're not going to respond to the 32-bit version. These are older, again, opto ESCs. The opto meaning that they don't feed 5 volts back out. They don't have a battery eliminator circuit. I'm going to be dealing with getting 5 volts a completely different way. So we only have the 2 wires coming out, signal and ground, and then we have ground and red for power, and then we have the 3 wires coming out to go to the motor. So what we're going to do at this point, I've already flashed this one because I wanted to make sure the process worked before I did this on camera. I made a fool of myself. So I'm going to go ahead and once again check your viewpoint. Okay, move these out of the way. I'm just waiting for my soldering iron to get up to temperature. I'm going to go ahead and remove the wires that I had attached to this one. It is important to note that if you're going to use an ESC in a fashion where it's being used and where it's going to draw 20 amps, you're going to want to use much thicker wires than this for power. But since we're only using this to flash the ESC itself, we're not going to be drawing much power. So I used whatever wire I had laying around. Give you guys a closer look at what I'm working with. Okay, so looking at the screen now, you can see under the microscope basically what makes up an ESC. We have a microcontroller, right there, which will hold the firmware and interpret the signals that are being sent down the line, whether that is a PWM signal, whether that is a one-shot signal, whether that is a D-shot signal. Now, if you don't know what these are, that's fine. There's a video coming up in the near future talking about controlling these from an Arduino, and we're going to bring in the code from consuming iBus and come up with an entire solution that will drive these motors that way. That video will be coming up pretty soon. Right, and then we have a few MOSFETs and capacitors that handle the actual high level of voltage and current that go through these ESCs. These are 2 to 4 cell ESCs, so they're expecting anywhere from 8.4 to 16.8 volts. I have my lab bench power supply set for 12.4, which should be more than enough to feed these to programming. So this one was already done. I'm going to go ahead and attach the wires to the next one, and we'll get ready to start to program, and then we'll talk about the pinouts and how to connect it to the Arduino. Again, this is a temporary soldering job, so you don't have to be very precise with it. So we have this ready to go. Just make sure that my bench power supply is currently turned off. Alright, and we'll take the power leads from ESC. We'll go ahead and set them into holes here. Make life a little easier. So now we need to figure out how we're going to work with the Arduino. The beautiful thing about the BlHeli suite is it does contain the ability to program the Arduino to be a BlHeli programmer. So the first thing we're going to do is we're going to go to Make Interfaces. Right, the board is a Nano or a Pro Mini. I'm using a Pro Mini 15 volt 16 megahertz. We choose that. Right, and I'm going to choose the Arduino 4-way interface. The reason I'm choosing the 4-way interface is because if I want to use this later, that will allow me to program up to 4 ESCs at the same time. This can be handy when you want to verify that they all have the same settings. So in the essence of an RC vehicle or a combat robot, where I'm going to be using 4 of them in order to work with this, it's very important that they all have the same settings, or this is going to get weird fast. So we click the Arduino 4-way interface. It brings up a choice for us, which isn't really a choice since there's only one. So we click OK, and what this is going to do is it's actually going to go ahead in the background and bring that window over here that opened up on my other monitor. And we want to, of course, choose the multi-V. That again allows us to program multiple ESCs at once. And when we click OK, or yes in that case, what it's going to do is it's going to go ahead and it's going to launch AVRDude and write an Arduino program to that Arduino. Now, once it's done, you get a done thank you, which means that the program is over there. Okay, we can go back to here. Now, one of the traps for new players that comes from this is the pinout. Those people who've done the the Nano tutorial, on the Nano, pin 3 is the first ESC. On the Pro Mini, pin 11 is one of the ESCs. If we take a look at the actual pinout, pin 11, pin 10, pin 9, pin 8 are the channels for the ESCs here. We're using pin 11 because it's just the easiest one for me to do from the beginning. So I'm going to connect the ESC to ground, and I'm going to connect the ESC signal wire to pin 11. Okay. So now, let's get that out of our way, and we're back at the programmer. Right, if I go ahead and click connect, it should connect to the Arduino. Now this is just connecting the PC to the Arduino. This has nothing to do with the ESC yet. Okay, and then we'll click read setup, which will attempt to talk to the ESCs and pull their current setup from it. Okay, obviously it didn't see one because there's no power attached to the ESC. It's a reminder to always Look over your connections before you power up a circuit. So, with that corrected, we power up the ESC. I show it at 12.4 volts and drawing no amps right now, which is exactly what I would expect. So we're going to click OK, and then we're going to click. It did find ESC1 that time. Read setup. We're going to flash BlHeli. Now, the BlHeli configurator here is intelligent enough to only suggest firmware that is compatible with this ESC. So it wants to install 14.9 of the favorite little b 20 amp BlHeli firmware. So we're going to click OK, and we're going to tell it to flash that. I'm going to be taking each of the ESCs up to the latest version this way. Well, the latest version will support anyway. That one is done. Alright, so the first option that we see is closed loop mode. Now, what this does is it takes in a value for the PWM signal that's coming in over the signal line, and the ESC will then translate that into an RPM value. It will then try to use a PID loop internally to maintain that RPM value regardless of how the motor is performing. This is good if you don't want to do this. So I don't know if I want to necessarily deal with that side of things on my controller or for my robot. So I'm going to temporarily just set it to a mid-range loop. It does give you the ability to change the P and I values for that PID loop, and you can definitely mess around with this to get exactly what you want down the road. I probably will. These probably won't be the last values that I do. The next one that I wanted to look at is motor gain. So motor gain is part of the PID loop process as well. It is a setting that controls the difference between speed error and motor power. It seems like it would control the aggression at which the ESC tries to correct and get back to the RPM that it wants to be at. Okay, so the next one is startup power. I've always left this at 1.0. Okay, so what startup power is it controls how the ESC responds to rapid throttle changes. For the most part, you do not need to change this setting unless you are having problems with your motors. This is, again, more from the helicopter or quadcopter side of usage of the ESC, so we're just going to leave that at its normal setting. Temperature protection is exactly what you think it is. If the ESC detects that it's going over temperature, it's going to shut down. In a combat robot situation, just like in a quadcopter situation or a helicopter situation, you don't want it to shut down. I would rather have the ESCs getting hot and me able to land than it falling out of the sky. And in combat robot, I would rather have it so that I control whether I push these harder or not. Alright, so for us, the next setting that we're interested in is brake on stop. We want to turn that on. Now what this is going to do is if you drop the throttle, it's not going to let the motors free run. It's going to actively fight them. It's going to draw power from the motors back into the ESCs, and it's going to try to use magnetics to assist in braking. The next one that we're looking at is the one that I am here for, because when you buy these ESCs, they're assuming that they're going into an aircraft, and the motor will only run in one direction. One of the ways that you would normally reverse it without reprogramming the ESC is just to change 2 of the 3 wire positions, and then the motor will go in the other direction. We want it to be bidirectional, which means it's going to read the PWM signal. You're going to lose half the resolution of that PWM signal because you're going to have a backwards gear, which is very important for us. We want to enable PWM input. This allows us to talk to this thing via PWM. I don't know what other interfaces that these particular ESCs use. It is possible that they will communicate via one-shot. Probably one-shot 125 is the newest communication protocol. I will come back in here, and the video that I'm going to do with controlling these with the Arduino is going to provide how to communicate with them via one-shot and how to communicate with them via PWM. It may seem straightforward that you just send a PWM signal and the motor spins. It's not quite that simple. The startup requires you to set minimum and maximum values before the motor will work. So we want to have maybe our own custom library or our own custom way of handling this that's going to prep the ESC and get everything up and running. BPM center throttle. Right, this is the throttle value at which the motor should change directions. So our center throttle right now is 1488. We'll have to take a look once we get the iBus values out of the transmitter to make sure that the zeroed or middle throttle is 1488 or in that neighborhood, and then we'll tailor this to that value. Input polarity, you can leave it the way it is. Startup beep volume, because this is going to be in inside of a battle box, I want to be able to hear what's going on, so I'm going to crank that up. Now, the ESCs do an interesting trick when they turn on. You may have noticed when we looked at it under the microscope, there's no speaker on it. It uses the magnetic coils in the motor to have the motor literally sing as a beep. It's kind of neat. If you want, I can do a video on it, but there's probably dozens out there already. PPM min throttle 1080. That would be in the case of the bidirectional mode. That would be full reverse, and max throttle 1852 would be full forward. So again, what we want to do with these three values down here is we want to get to the point of doing the experiment where we're consuming the iBus signal, we're sending a value to the ESC, and then we can set these to be precisely where we want them to be. But in the meantime, I'm going to go write setup to this ESC, and I'm going to do that 3 more times. But yeah. At the end of the day, that is how you flash BlHeli onto a SimonK ESC using an Arduino Pro Mini and the software provided for BlHeli, and start to get to the process of where we can use these brushless motors with things that don't fly. If you have any questions, comments down below. I want to thank you for joining me in the lab. I hope you learned something today, and we'll speak again soon.